Okay, so this will be a short video on how to create the inverse T program for the Ti-83. If you do happen to have a Ti-84, it does have the program innately in there. If you go to second bars, inverse T. However, the Ti-83 does not have an inverse T function. So what we're going to do is manipulate it using the T interval, which we're going to learn about today. If you do have a Ti-83, I'd suggest you watch this video first so you can go ahead and practice with us whenever we get to the T intervals. So first, how we derived at this program, how we manipulate the calculator to give us what we need. Here's our formula. It's a confidence interval, so the mean plus or minus the error is what the confidence interval is. So the first thing we need to do is make this x bar, our mean, 0. That way it's just our error as our boundaries. Here's our error formula. So if we take the square root of n right here, those just cancel out, and we're left with z of alpha over 2. And since we're using n, we let square root of n be our standard deviation, and we let n be n, then we have the correct number of degrees of freedom, and we get the z of alpha over 2 for our value. So let's just test that out. So if we go to a T interval, so stat, test, number 7 is V interval, number HV T interval. And we're going to make sure we're on stats here. We'll probably start off on data. Looking like that, we want to be on stats. Make sure X bar is 0. And then pick a number for n. I have 23 here, so if I do square root of 23 for my n, for my standard deviation, square root of n, that will let me get whatever alpha value I need. Now we're going to look at the complement of the alpha value. So this is the 95% confidence. So if I wanted the 95% confidence, 2 tails, 5%, 2.5% either tail, this would actually give me the T score for 2.5%. Let's see what it is. Takes a minute sometimes. So I should get 2.074. Let's look on the chart. So degrees of freedom is n minus 1. So we had 23, and so we had n is 23, degrees of freedom is 22. We had a 95% confidence, which that's the area in 2 tails would be 5%. The area in 1 tail would be 0.025. So we're going to look at this one, 2.074. So that's exactly what we're going to do to manipulate the calculator to give us what we need. So here's the program if you want to just pause it and type it in. I'm going to go step by step in a minute in case you're not familiar with this TI programming language. So first thing we need to do is create a new program. So I'm going to create a new one. I already have inverse T in there, so I'll name it inverse T2. So you're going to use these letters right here. IN, V, T, and then I'm going to turn alpha off and put a 2. Since I already have inverse T program written to make sure I could get it properly posted here for you, I'm going to call it number 2. So here we go. Here's how we do it. I'm going to turn, not that, key presses on so you can see exactly what I'm pushing on the calculator. So you're in your new program. First thing you're gonna do is clear the home screen. That's what I always do in the first line. So you're gonna go to Program, Input Output, number 8, clear home. The next thing we need to do is get some input from the user. We need 2 things in order to determine the T score. We need the degrees of freedom, and we need the alpha value. So let's get that from the user. So to get things from the user, we're again going to go to Program, Input, Output. We need an input, something from the user. If you're lazy, you could also use a prompt, but you can't display a nice message whenever you prompt. So I like to use input instead. Makes it a little clearer on what we're doing. So I just hit second alpha to cap lock, and then plus sign to put my quotation mark. Anytime you're going to use words, they need to be in quotations. Now I'm going to spell out alpha because there's no alpha symbol on the Ti-83. Now I want an equal sign. To get that, I'm going to hit second math. And there's my logic, equal signs first one. And close my quotation mark. Again, alpha plus sign. Okay. I'll go back through this if you need to see it. Make it bigger. Clear that. Now after we have that, we're going to put comma and whatever variable we want to store it as. I like to call alpha A. Then we hit enter to go to the next line. And then we can either get the degrees of freedom from the user now or fix alpha to be a confidence interval. Because what the calculator reads, what it wants whenever we do a confidence interval is the confidence level. So what we're going to do is 1 minus alpha. Oops. Alpha. However, whenever we're doing a confidence interval, it's always in 2 tails. But we want to make it to read an alpha for a 1 tail. So we're going to double that. That way, if we're looking for an alpha of 0.05, what's going to happen is you're going to type in, 0.05, and then we're going to subtract twice that. So we're going to subtract 0.10, so we'll have a confidence interval of 0.90. So that would create the correct confidence interval for us. Okay. Somebody wants to say hi. Hi, thank you. That's Mommy. Oh, that's Benny's phone. Thank you. She brought me my phone. The next thing we need is the degrees of freedom. So we're going to go to, again, Program, Input, Output. And we need the degrees of freedom now. Now you can just put df for degrees of freedom. But since the calculator has the variable on there, I like to use it. So how you get to that variable is you go to bars, statistics, and you're going to look for it in here. Somewhere in here. Oh, there it is, in tests, number 6. So input degrees of freedom, second test, equals. She needs her phone, Mommy. Oh, there it is. So degrees of freedom equals, and then we're going to call that D, or whatever you want. You can call it X for all that matters, as long as you put the correct variables down at the bottom. Now we don't need the degrees of freedom. What the confidence interval takes is in the n value. So we're going to take our degrees of freedom and add 1 to them, and call that, n. Okay. So now we've got the data we need. We're going to run our confidence interval. So stat test number 8. See, there it is. And now we're just going to type it in like we did whenever we're typing it in on the other screen. First, we start with our mean, standard deviation with square root of n, then our n, followed by our confidence interval, which we called C. Now this is going to run the T interval, but it's not going to show us anything. So what we need is to actually see what that z-score is, what our confidence interval is. Now, if we look at the chart, they're rounded 3 decimal places. So that's what I'm going to make the calculator do now. So I'm going to go to mode, and I'm going to fix it to 3. All right, 3, and hit enter. Now that's going to say, hey, calculator, round all my next answers to 3 decimal places. And then we're going to display. Again, we're going to go input, output. Number 3 is display. Now, what do we need to display? We need to display the upper bound of our T interval. Since the T interval, the lower bound will be the negative number, we just want the positive. We can take what we need from there. So we're going to go to vars, statistics, number 5. And I believe that's in tests. Yeah. I went up to get all the way to the bottom, upper. So then that's going to give us our T-score. Before we finish the program, though, we want to put our calculator back in the proper mode. So we're going to go back to float. That way it'll store all the decimal places and round it properly, fill up the screen with decimals if we need to. And that's it, we're done. Let's test it out. Second mode to quit. And now we're going to go to program. I'll use inverse T2 since, that's what we just did. And it prompts alpha equals, well, how about 0.05? So this is in a one tail, remember? So this is 0.05 in one tail. Degrees of freedom, I don't know, 27 or 17, 31. It does take a second. So if an alpha value of 0.05 and 17 degrees of freedom, we should have 1.740 for our T critical value. Let's look. Degrees of freedom 17. So we're here. And 0.05, my head's in the way. 0.05 and one tail. Here it is. 1.74. So 17 degrees of freedom. 0.05 and one tail gives us 1.74. So now you have a fully functioning inverse T program on your Ti-83 calculator. Casio's, sorry, you're out of luck. Just got to use the chart.